Hello my dear children. Our next topic is colligative properties that are going on. There are 4 colligative properties, The first is lowering in vapor pressure, elevation in boiling point, depression in freezing point, and our 4th is osmotic pressure. 3 properties we have already covered. Today's topic is write down osmotic pressure. Now, this is the 4th colligative and the last colligative property. Before taking this property, let us share what is osmosis. First of all, I will tell you what is osmosis. Write down osmosis is the flow of solvent from dilute part to the concentrated part. Osmosis is the flow of solvent, or you may say less concentrated part to more concentrated part, or you may say dilute part to concentrated part. So this is osmosis, but the osmosis is always through this flow through SPM. What is SPM? It is a semi-permeable membrane. Semi-permeable membrane. Write down SPM. It is a semi-permeable membrane. It allows only the solvent molecules to pass, but never allow the solute to pass because of the larger size of solute. SPM only allow the solvent molecules to pass. Now I will draw a diagram to explain you thoroughly. First osmosis, and after osmosis, when osmosis will become clear, then I will come on osmotic pressure. Now for osmosis, draw a diagram along with me. Draw a diagram. Make 2 compartments, right hand side and left hand side compartments. And partition is through SPM. SPM, semi-permeable membrane. To right hand side, take simple water. Write down water here. That means it's a dilute part. And to this side, take water plus NaCl, or you may take any other solute, but it's a solution, right? Solution. Because it is simple water, it is dilute, it has water and NaCl solution, so it's a concentrated. The right hand side is a dilute because of only water, left hand side is concentrated because of NaCl also in it. Osmosis will start. There is a flow of solvent is on both sides, water, but there is a flow of solvent, make arrows, from dilute part to the concentrated part. This is a very interesting phenomenon of the science which only takes place from dilute to concentrated. Rest all the phenomena of science takes place from high to low. Heat flows from high temperature to low temperature. Gases flow from high pressure to low pressure. And diffusion takes place from high concentrated to low concentrated region. Then why there is only one phenomenon of science which takes place from dilute to concentrated? So it's a very interesting theory that only there is one phenomenon of science which takes place from low to high. Others takes place from high to low. High to low, to balance the equilibrium, high to low. So it's only one which takes place from low to high. How? Because there is water. If you remember those 2 beakers, then the idea came in your mind that where there is only water, the write down vapor pressure is more. And when there is a NaCl addition in water, remember those 2 beakers where I have put NaCl in water and NaCl has occupied the surface. It has decreased the area. That means it's decreased the escaping tendency of the vapors. That means this side vapor pressure is less. So here vapor pressure is more, here vapor pressure is less. To equalize vapor pressure, osmosis takes place from this portion to this portion, from high vapor pressure to low vapor pressure. I think it's a very interesting phenomenon of science. Now you came to know why is the only osmosis of the scientific phenomena that takes place from low to high. Because of this. Because of water, vapor pressure is more, and here because NaCl comes, it occupies the surface, it decreases the area, it decreases the escaping tendency of the vapors. This is osmosis going on. Okay, this is the first diagram. So what is osmosis, students? Osmosis is the flow of solvent. Solvent. Never say solute. Solvent from less concentrated to more concentrated part. Okay, now I am trying second diagram. Now this is my beaker. In this beaker I have taken simple water, and this is my funnel, thistle funnel. Thistle funnel. This is one of the equipment of chemistry. THISTLE. Thistle funnel. This is a mouth. Let us close the mouth by SPM. Make it SPM. This is SPM. Tie it with a thread. It is SPM. And fill sugar solution in it. It's a sugar solution. It's a concentrated. It's a sugar solution. Write down. In the thistle funnel, you have filled a sugar solution. Now students, osmosis will take place because this is your water. In a trough, there is water, that is, it is a dilute. But in this case, in the thistle funnel, there is a sugar solution, it is a concentrated. Now you know what is osmosis. Osmosis is the flow of solvent from dilute, right, along with me, from dilute part to concentrated part. This means the water, this means this level go on increasing. Now you know what, why the level go on increasing? Because there is an entry of the solvent from the dilute to the concentrated. So its level go on rising. That means osmosis is going on. But a stage will come when the levels stop rising. Write down. A stage will come, a time will come when the level stop rising. Students, when the levels stop rising, understand this is due to, write down, this is due to osmotic pressure, OP. OP is osmotic pressure. When the stage where osmosis stops because of osmotic pressure. So here osmotic pressure has been built up naturally. Naturally it has been built up. This means, write down, osmotic in this diagram, how will you call what is osmotic pressure? Write down, it is the natural, it's a natural hydrostatic pressure. It's a natural hydrostatic pressure that P is equal to HdG, the height, density and gravity, that has been built up in the apparatus due to osmosis. Due to osmosis. So this is your osmotic pressure. Osmotic pressure, osmosis stops naturally. It stopped naturally. Sugar level first rising. After some time, sugar level stop rising. When it stop rising, you will say osmosis stops. The stage where osmosis stop is called osmotic pressure has been developed in the system. Now, third diagram. One by one, when I will make the diagram, you go on drawing with me. Only then you came to know what is osmotic pressure slowly and slowly. Now, third time. Make a diagram again along with me. Partition of SPM again. It's of SPM. This side take dilute part. This side take dilute portion. Water, that is simple water. This side take again same diagram, repeat. This side take water plus sugar. That is, if you add sugar and water, it's a concentrated. Okay, it's a dilute, it's a concentrated. Osmosis is going on smoothly from dilute to concentrated. Now, students, you want to stop the osmosis. You want to stop the osmosis. This osmosis is going on from dilute part to concentrated part. That is because there's SPM, so osmosis is going on. Water is this side, water is this side. That everything I have taken already. Osmosis always takes place from less concentrated to more concentrated. Now my question is, we want to stop osmosis. What we will do? When we want to stop osmosis, we will put some pressure. Make a diagram. This is my weight. This is a pressure. I am going to apply pressure. Right? I am going to apply pressure on the solution side. on the solution side, because osmosis is coming, because solvent is coming this side. When I will put a piston, that is a piston, I applied pressure on it. The moment I apply pressure, going on applying pressure, more and more pressure, a stage will come when the osmosis stops. Osmosis stops. Now there is no flow of solvent to this side. Now students, the stage, the pressure at which osmosis stops. This pressure is applied by us now. This is not naturally built pressure now. This is a pressure which is applied on the solution side. Why? To stop osmosis. So this is osmotic pressure. This is osmotic pressure. You may represent it by P or you may represent it by, remember it. Represent osmotic pressure by P or by pi. So this is osmotic pressure. So now what is osmotic pressure? It is a pressure which is always applied on the solution side to stop osmosis. Now I'm taking last diagram, fourth diagram. So osmotic pressure is a pressure which is applied on the solution side to stop osmosis. Okay, now again make a diagram. Let it is your SPM. Make it SPM, semi-permeable membrane. It is a membrane which is present. It's a naturally available in every fruit skin, vegetable skin. Remember this. SPM is a natural membrane found in animals, that is plant cells. What? That is in skin of the plants, fruits. So that's the reason. Your shriveled carrots, shriveled radish, shriveled flowers get fresh when you put in water. Water is dilute, and that is your cell sap is concentrated. When you put vegetables in water, when you put your flowers, dry flowers in water, it becomes fresh due to osmosis, because of flow of water from dilute part to the concentrated part, that is cell sap, SAP. This is my SPM, this is my fourth diagram. Again write down pure water now. Please write down pure water. And this side I have taken sea water. Sea water. And do you know which water is concentrated? Sea water. Why? Because sea water has a water as well as NaCl. So sea water is very concentrated, and this pure water is dilute. Write down dilute, and sea water is concentrated. So what is going on? SPM is there. So because of SPM, osmosis will take place from dilute to concentrated, right? Osmosis taking place from dilute to concentrated. Students, I want to stop osmosis. You know what I will do? I will apply pressure on the solution side. When I will apply pressure on the solution side, a stage will come. A pressure will come when there is no flow of solvent from dilute to concentrated. Make it cross now. Now osmosis stops. This is osmotic pressure. But now listen to me carefully. I am going to apply more pressure. That is pressure greater than OP. Write down. Now I applied more pressure. When I apply more pressure on the solution side, now there is a reverse RO system. There is a reverse osmosis takes place. What's the reverse osmosis? The flow of solvent now. Flow of solvent from concentrated to dilute part. Flow of solvent. So what left when there is a flow of solvent to this side? You can make a exit here. Let it is an exit. This is your water. This water total will come out. This water is, you can use this water, this is purified water. You can use this water for drinking purpose. And here what left? In this compartment now only NaCl left. NaCl left. So students, remember, this reverse osmosis is a method used for the desalination of seawater. What's the application of reverse osmosis? It's used for the desalination of seawater. That is to extract salt from the seawater. I think you understand what is osmotic pressure and what I have done in this case. I have applied a pressure greater than osmotic pressure on the solution side. When I will apply the pressure greater than osmotic pressure on the solution side, then what will happen? Then reverse reaction takes place. There is flow of solvent from concentrated part to dilute part. That is a reverse osmosis, RO. Reverse osmosis takes place, and write down its application. It's used for the desalination of seawater. So this completed my topic osmosis. Let us start osmotic pressure. Osmotic pressure, now it is clear. It is a pressure at which osmosis stops. It is represented by P or pi. So let us start driving that it is a colligative property. Osmotic pressure is directly proportional to concentration. Pressure is directly proportional to temperature. Add it. This means pressure is directly proportional to Ct. Make it constant. Proportional is R. It's a RCT. What is a concentration? Concentration we have done in very early pages of chapter solution. Concentration is NYV, that is number of moles per liter. Put the value concentration here. This means this comes P is equal to N by V RT. That means PV is equal to nRT. Make it round. For this, in the next lecture, we will take the numericals. Now, PV is equal to nRT. This means P proportional to N. Any property which depend upon the N is a colligative. So that clears osmotic pressure is a colligative property because it is directly proportional to the number of moles of solute. You can write, hence it is proved OP, osmotic pressure, is a colligative property. Now write application. Every colligative property has one common application. That is, it is used to determine capital M, molecular mass of solute. Write down application. Application. PV is equal to N. N is small m. Small m by capital MRT. You can write small m or you can write W, weight of solute. Now you can make capital M. The capital M is equal to small mRT RT by PV. Capital M is equal to small mRT by PV. So this application, this is every colligative property has one common application that is used to determine molecular mass of solute that we will use in numericals. Next subtopic is, this is all about osmosis. What is osmosis and why osmosis takes place from dilute to concentrated? What is osmotic pressure? Naturally built pressure and synthetically built pressure that we have applied on the solution side. Reverse osmosis and what is the application of reverse osmosis. Prove osmotic pressure is a colligative property. Now I am taking topic subtopic. What are isotonic? Write down ISO, isotonic solution, hypertonic and hypotonic. Right? Isotonic solutions are those which have the same osmotic pressure. Two solutions have the same osmotic pressure. They are isotonic. Remember, 0.9% NaCl, 0.9% saline water, NaCl, or you may say saline water, SALINE, saline water, is isotonic. Isotonic means same osmotic pressure with RBC. Remember this, 0.9% NaCl is isotonic with RBC. Right? This is one of the best example of isotonic solution. That's the reason during giving intravenous injection, doctors take care. What I'm telling you in detail. First of all, write down what are isotonic solution. Hyper means one solution has more osmotic pressure than other, and hypo means less osmotic pressure than other. So isotonic is the main same osmotic pressure if the two solution, and this is one of the best example. 0.9% NaCl is isotonic with RBC. I'm taking two beakers. Make a beakers along with me. In one beaker I have taken 0.5% NaCl. that is less concentrated part. In another beaker I have taken 1% NaCl, right? And this is my RBC. Write on RBC, RBC. Now, here RBC is put in concentrated solution. Here RBC is put in less concentrated solution. You know there is a SPM in this RBC under the skin. Now what will happen? Now, because dilute to concentrated. So osmosis is from dilute to concentrated. So here osmosis takes place from RBC to this NaCl, dilute to concentrated. Arrows outside, dilute to concentrated. Here dilute to concentrate, inside. Here NaCl will go inside. So in both cases RBC will burst. Here RBC will swell and burst. Here RBC will shrink and die. Shrink and die, swell and burst. So that's the reason during giving intravenous injection, doctors always takes care that the injection solution must be prepared in 0.9% NaCl. It should not be hypotonic and it should not be hypertonic. Otherwise, what will happen? Now you can see RBC will burst and it will die. So this is the reason during giving intravenous injection, doctors always take care. Now next subtopic, my request to all of you, do yourself because it's a very simple topic. It's application of osmosis, and we have seen so many application of osmosis in our daily life. So many application of osmosis in our daily life, which that is during flowering, when we give water to the plants, that it is your soil, these are seeds, you give water to them, then water, this is your stem, slowly and slowly, branches, flowers, fruits, that is total flowering, fruiting of the trees, this total depend upon osmosis. Water flow from dilute part, this is dilute, when you give water to the plants, dilute part to the concentrated part, that's a plant cell, same. So total growth of the plants depend upon the only one method, that is osmosis. And this is a very, very important, that is growth of the plants totally dependent upon osmosis. Fresh vegetables, that is fresh flowers, you can take within minutes when you put dry things in the flower, that I have discussed. This is so many daily life osmosis examples are there given, so you can read yourself in the NCERT. So this completed my all 4 colligative properties. The one is lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Now in my next lecture, we will start the numericals of all these 4. So my request to all of my children, please bring NCERT, because in my next lecture we are taking numericals of all 4 colligative properties. Thank you. Take my lecture regularly. Thank you.